Okay, so finally the the file is open. This is what you're going to be greeted with when you're going to open your C# script. So if this is your first time programming, there will be new concepts that you're going to learn. If this is not your first time programming, again, you're going to learn a different concepts. Um, so let's start with your void start method and your void update method. So people who are familiar with programming, sorry, sorry, yes. So people who are familiar with programming, they know that you write most of your code in int main, or there's some sort of like a main function in which your code is running, right? And then you have different functions which can be called in the main and so on and so forth. But in Unity, we don't have a main, right? So as you can see over here, there's no main. There's a void start method and there's a void update method. And over here, you can see it says that a start is called before the first frame. So you can imagine when you're starting your game, right? When I'm going to click the play button on the game, this start method will run first and it will run only once. So to show you that, I'm going to write debug.log, and over here I'm going to write this is only uh, this is start method, and we're going to save that, go back to Unity. This is going to compile the script. Right now, for your script to actually work in your game, you need to attach that script to any game object, right? So I can attach this script to a cube, or even if I want to create like an empty game object, I can also attach this over here. So once I'm going to hit play, um, this is just going to complete the, yeah. And over here, you can see in the console, so you can imagine this is your CMD console. This is showing, yes, that this is the start method was printed. So in Unity, you're going to be printing your statements in the form of debug.log just to check if something is working, if something is not working, what's the value of a variable, anything that you want to print basically in your console or in your in your console, you're going to do that using debug.log. Now, an update, on the other hand, is a function which is called every once per frame. So you can imagine, like, when you're playing a game, right? Everything is being recorded in real time. So when I'm going to like debug, so when I'm going to like debug this thing, this method, you will find that this message is going to be printed every frame. So I'm going to hit play. You can see in the console that you can see the amount of messages. It's increasing, which means that this update message is being called every frame. Meanwhile, if we look at the very start, this is start method was called only once. So a start method is used when you want to do mostly your initializations of variables, of different controllers and different components. That's all of the initialization part is done in like the start method. And anything which you want to check, right, which is going to be affected every frame. So for example, a cube which is going to move, right, that's going to be written in the update method. So let's start with solving a problem of moving the position of this from 727 to 000. So initially what I want to do is when I'm going to hit this play button, I just want its position to be at 000. I don't want it to move. Basically, I just want it to snap. So the way how I'm going to do that is by writing a code inside my start method, and inside this start method I'm going to write transform dot position equals to new vector 3 0 0 0. I'm going to save that, and we're going to play this and see what happens. Also, you can also use a shortcut Control P to play the game. You don't have to manually go over here and click the play button. So yeah, and it didn't do anything. So the reason as to why it didn't do anything was because if you look at the game object, the translation script is applied over here, right? But if you look at the cube game object, nothing, there's no script applied to this cube. So you need to drag and drop your script onto your cube game object. So now if we hit play, as you can see, its position got snapped to 0 0 0. Okay, so what did I do? How did I write this line of code? So transform.position comes from this component, right? So what I'm saying over here is when the game starts, take the transform component of the game object on which this script is applied to. So transform, go to cube, transform, get the transform component, and at that transform component I want its position component. So then you just write transform dot the position component, and when you're going to hover your mouse on the position, it says vector 3 transform the position get and set. So people who are familiar with programming with getters and setters, basically getters are used for getting the information, and setters are used for setting some information. And right now we're using this transform.position as a setter because we want to set its value to a new vector, which is going to be at x position 0, at y position 0, and at z position 0. And the reason why we're writing new is because we want to change its position, the original vector's position, to a new vector. That's the reason why we wrote new. And since because it had 3 components, x, y, and z, this is a vector, right? That's the reason why we wrote new vector 3 0 0 0. All right, so if we want to see what was its original position, or if we want to see what was the position of this transform.position after it got displaced to 0 0 0, we can do debug.log and then write transform.position. Transform.position. We're going to go back here. And we're going to hit play. And what you will find is that the debug statement is going to be printed twice. And the reason why it's going to be printed twice is because once it is 7.48, 2.53, 7.56, that was its original position. And this 0, 0 was also printed. But if you see over here, there was no statement after this transform.position. So why did this 0, 0, 0 was called, right? Why was this printed? It was printed because the script of translation was not only applied on the cube game object, but also on this game object as well. So if I remove this component, so let me just get out of the play mode, and if I remove this component from over here, and if I rerun this, you will find that it will only print the message once, which is going to be at 7 to 7, something like that. So console, see, it just gets printed once. So sometimes when you're starting off with Unity, sometimes you forget that you have applied some script on some object. You can also sometimes apply the same script twice as well. These are some beginner mistakes that most beginners do. So make sure that the script is only applied once. Sometimes you want to apply it twice, but usually most of the times you don't. It's a very rare case. So these are some beginner mistakes that you need to look out for. Okay, so as we saw, we changed its position. Now let's do something different. Okay, um, okay. So the next thing that we're going to do is we're going to press some key, and if I'm going to press that key, I'm going to print which key was pressed from my keyboard. So basically I want to take an input from the user or from whoever is using this application, and I just want to see which key was pressed and print its print its key name. So the way how we're going to do this is we need to constantly check if a user is pressing a key or is it not pressing a key. And the way how we do that is by using an if condition. So we are going to write if, and in this if condition, we're going to say input dot get key. So get key, and now you're going to get three things. You're going to get key down, and get key up. So get key down means key was pressed. Get key means, so get key down means, and get key means key was hold on to. So if you're holding a key, then you would use get key. And get key up means, as its name states, the key was released. So in this case, we're just going to use get key down over here. So input dot get key down, sorry, not get button down, but get key down. And in this get key down, we're going to then write which key was pressed. So for this, we're going to use key code dot, and when you're going to write key code dot, these are now going to include all of the keys which are available on your keyboard. So A, B, all of that. It's also going to include the keys from a controller. So if you have a PS4 controller or some other controller, it's going to also contain those keys as well. So for now, we're just going to say, hey, if I'm pressing the E key, what I want to do is just debug.log and say E key was pressed. So now let's save this, go back to Unity, and test this out. So I'm going to hit play. Go on console, or basically on game, and let me just dock my console over here so you can easily see. Now if I'm pressing my E key, you can see E key was pressed. And every time I'm going to press the E key, you can see that this message is being printed. I'm not sure if you can hear me pressing the E key, but I am actually pressing the E key. So you can also experiment this on your own and see how it works out for you as well. I'm not gonna go into the writing a code for get key and get key up. This is going to be your task. So we're going to experiment with this, and you're going to see what effect does get key and get key up does as compared to get key down. Okay, so now that we have learned how to basically press a key, and if we can see which key was being pressed, the next step is going to be to actually it's going to be to take some input by the user and check if it was in the right direction or was it in the left direction. So what I mean by that is the next task that we're going to do is we're going to check if the user or if the player presses W or A key, and we are going to check its horizontal input. Right, so if I'm going to press the W key, it should mean that I'm going to, sorry, if I'm pressing the A key or the D key, so if I'm pressing the A key, then that means I'm going towards the left. If I'm pressing the D key, which means I'm going towards the right. So we need to somehow check if the player is pressing the A key, if it's going towards the left, or if it's if we're pressing the D key and it's going towards the right or not. So to do that, the procedure is going to be the same. We're going to constantly be checking in every frame in the void update that is the player pressing any key or not. Is it pressing the A key or is it pressing the D key or not? And the way how we're going to do that is we're now going to write input dot get access, and in this get access we're going to write horizontal, and we're just going to debug.log this statement over here. So again, I will show you the effect of this code and then I'll explain to you as to how I got to this code. So okay, so let me just write this over here. If the player presses the A key, it should print it would print -1 because that represents I'm going towards the left. And if the player presses the D key, it should print +1 because that means I'm going towards the right. So again, let me just dock this over here. You can see it's constantly printing 0, and the reason why it's constantly printing 0 is because update is being called every frame. So I haven't pressed any key as of now, so right now it's assuming that it's at the neutral position, which is 0. So now I'm going to press the A key and you will see that this value is going to change from 0 to -1. So as you can see, it changes to -1, and when I'm going to release this button, it goes back to 0. Now I'm going to press the D key and you'll see that this is now going back to 1, right? And if I'm going to remove my hand from the D key, it's going to go back to 0. So perfect. So how did it basically know that if I was pressing the A key, it should print -1, or it should, it should print -1, and that's being reflected as a left direction. And if I'm pressing the D key, it should print +1, and that's being represented as a right direction. The reason is because in most games, WSD is a very standard movement keys, right? So W represents upwards, S means downwards, A means left, and D means right. So to avoid writing the code that we saw over here again and again, which was like, hey, if the key is basically if input dot get key key code dot A, if that's the case, then hey, debug.log A, and to avoid this repetition of code, when you're going to go to your file, or not file, in edit over here, and in edit you're going to go to your project settings, and in your project settings, if you go to your input manager, and in your input manager go to accesses, and then in the horizontal you can see that what we basically did was we wrote input dot get access the horizontal, and this horizontal description, or this all of these details have already been mapped, and basically it has already done the functionality for you, which is that if I'm pressing the left key, which is the arrow left key, or I'm pressing the right key, this is going to act as a horizontal -1 or 1. And you can also see that you can change the gravity, you can check the dead zone, the sensitivity, and all of that stuff. And similarly, if we look at the vertical key, it is already mapped to down key, the down arrow key, the up arrow key, and so on and so forth. So some of these input manager, this input keys stuff has been done already for you. So you don't have to write tons of code just to get the basic movement done. You can just use the input manager and get your work done from over here. Okay, so that's what I did. I went to input, then went to get access, and then I wrote horizontal over here. Perfect. So now let's do something interesting. And now what I want to do is, when I want to move the cube Yeah, so basically now I want to move the cube by pressing W, A, S, and D. Okay, so when I'm going to press these keys, W, S, D, I want it to move in that direction. So how are we going to do that? So to do that, again, we are going to first look at as to how to move a cube. So to move a cube, we're going to go to transform, and instead of changing its position, um, if we open its reference, so let's see, yeah. So one thing that we're going to do is we're going to open its documentation for a little while and show you how we're going to move this object. So over here, you can see that they have a very nice documentation. You can always go to Unity manual and you can check its documentation over here where they're explaining you what each component does. So the position over here, as you can see, is the position of the transform in the XYZ coordinates and so on and so forth. And how you're going to edit the transforms. All of this stuff was explained to you in the last video. But what I want to see over here is where is it? Switch to scripting. Okay, so yeah, in the scripting over here, you can see that there's a function called, where is it? Where is it? Let me maximize this. Okay, let me just search it up. So there's a function called translate, and what a translate function does is it moves the transform in the direction and in the distance of the translation. So this is going to be the function that we're going to use, transform.translate, and this is then going to allow our cube to move in the game. So over here, we're going to do the same thing. We're going to write transform.translate, and in this it's asking us for the position. So the position that we're going to set is going to be, let's assume 1, 0, 0. So this is your X movement, right? And since X is set to 1, it would move in the X direction with a magnitude of 1. So let's get back to the scene view so you can see it very clearly. And now when I'm going to hit play, it's going to move in the X direction. And wait for it to compile. And as you can see, it is in fact moving in the X direction with one unit. But as you can see, it went way too fast. And as you remember earlier, I told you that the update is being called every frame, right? It's not being called every second. So if you want to see your movement to be displayed in every second, you have to multiply. So one thing that I'm going to do over here is we are going to create a variable and call this public vector3 and call it right direction, and we're going to call right direction equals to new vector3 and set it to 1, 0, 0, 0. And instead of calling this over here, we're going to just write right direction. So we're going to save this, and I'm going to explain you as to what I did. So I just want to check if this is working or not. Hopefully it would work. So hitting play. Okay, yeah, so it's working. As you can see, it's working. Okay, so what I did was I created a public variable. So I created a public variable of type vector3, and I called it right direction. Whenever you're going to create any variables, right, may it be public, may it be private. So I'm going to get into what is public variables, what are private variables in another video. But as of now, the most easiest thing to work with is calling public variables. So if you want to create any variables, you're going to create public public, the data type, and the variable. And what I did was I went into the void start where I said I do most of my initializations. And in this right direction, I said that, hey, set its value to 100. And then in the update method, I just said, hey, I want to translate my position or my transform.position in the vector of 100. So just move in the direction of 1 comma 00. So 00 means don't do anything, and 1 means by that uh, magnitude. So initially what I'm doing is, you can imagine that this is my x position, which is going to be, so let's just copy this. So this is my x position, this is my y position, and this is my z position. And what my translate function is doing is that it is just increasing this with a vector of 100. So 1 over here, 0 over here, and then 0 over here. And this, since this is being called every frame, you can see that this is in fact being increasing every frame. But most of the times we don't want we don't want our position to be called every frame, because of the fact that in some computer systems your computer processing speed is different, and in some computers your processing speed is different. So in some computers your frames will be called very slow, and in some computers your frame will be called very quickly, because of fast processing speed. So to make sure that our game is being played at the same time, at the same rate in all the systems, what we do is we multiply this by time dot delta time. So most of the times you will see that you're writing, whenever you're translating anything, whenever you're trying to change the transform the position or the rotation or anything, you're always multiplying it by time dot delta time. And what it does is it basically says, hey, instead of moving my cube every frame, move it every second. And what this will do is this will bring a very smooth transition of your translation. So now if I hit play, now you'll see that this is going to move very slowly and it's going to be very smooth. Okay, it was still very fast. But yeah, a very nice practice is to actually use time dot delta time. Okay, so now that we're done with this, we're now going to get to our main objective, which was to move the cube by pressing WSD. So how are we going to move the cube by pressing WSD? So to make this a bit more simpler, let's just do it with A and D. And then as a task for you guys, you would be expected to do it for WSD for all of the 4 directions. So to do it for only 2 directions, I would somehow need to know if the user is pressing an A key or is it pressing the D key, right? So what we can do is we can say, okay, if, or instead of like writing if he's pressing the horizontal movement, so what I'm saying is, instead of like writing this thing, which is going to be input dot get axis horizontal, this logic basically means, hey, if I'm pressing the A key or if I'm pressing the D key, then do this thing, right? But this is not what we want. What we want to do is move the cube in that direction. So we need to know if he's pressing the A key or is it pressing the D key, and get its value. So that's the thing that we need to do. So instead of like writing this logic, we're going to create a new variable, call it public float, because as you can see, the horizontal variable's value was shifting from 0 to -1 and then 0 to 1. So we're going to say public float horizontal input. And in this update, we're going to say horizontal input equals to input dot get axis and right horizontal, and make sure that this is capitalized, this h, because it won't work. So now if we do this thing, now I know if it's pressing the 1 key or is it pressing the 0, if it's pressing the A key or is it pressing the D key, and I know its value because its value is going to be either -1, which means I'm pressing the A key, it's going to be 0 if I'm pressing nothing, and it's going to be 1 if I'm pressing the D key. And again, as you can see, it was the values were moving from 0 to -1 in decimal values, so it's going to bring a very smooth transition. So over here, instead of right direction, we're going to write horizontal input. Okay, we are getting an error over here. Cannot convert from a float to this. Okay, so I believe to fix this, what we're going to do is we're going to do right a direction and multiply that with that, and that should be different. So let's hit play. And now if I press the D key or the A key, you can see that it's being moved very slowly, right? But again, if I press the WASD, the W key or the ST, it doesn't have anything. And since my variables were public, you can also see these values being represented over here in the inspector. So when I'm going to press the D key, you can see that the horizontal input is 1, and in fact the value is increasing by 1. And when I'm going to release this button, it goes back to 0, and this is the new position. Okay, so this was like a very informal way to write a code for horizontal input. But the way how you normally do this is you instead of writing over here, you're going to wait. Dot position times horizontal input. Let's see if this works. Okay, so we're going to hit play, and if my logic is correct, it should work. Okay, that is not what it should have been doing. Yeah. So again, you would have to if it's being pressed in the if you want a horizontal movement, then you would expect it to have a vector of 1 0 0. So what I was trying to do is I was trying to like write a generic code in which you could like just write transform that position, and then from there you could just press the A and D key. That would do the trick. But no, you have to write a right direction vector and then multiply that to this horizontal input. Okay. Okay. One last activity that we're going to do is going to be changing the cube's color. So to do that, we're just going to remove all of the stuff, or we can keep this stuff. Yeah, we can keep this stuff. We're just going to create a new variable called public game object cube. And in the update, we're going to write cube dot get component, and in this component we need the mesh renderer, and in this mesh render, we're going to take its material and set its color to red. So again, I'm going to first of all demonstrate to you what's actually is happening, and then I'll explain you the code. So over here, we're going to attach our game object, hit play, and change its color to red. Right? So you can see it's red. Uh, Again, this is being rendered every frame. I think it's better if we do this over here so that it just changes its color once, and we don't want its color to be changing again and again and again. That's just going to reduce the number of calls and improve our performance a little bit more. So if I play over here, again, its color is going to change to red. So waiting for it to compile, and see, it is now red. So what is this code and how did I get to this code? So what I did was, first of all, as I said, you know what game objects are, right? So I wanted some reference to the game object as to which game object do I want to change the color for. You can do it using this thing. You can do it like writing it like this, or you could do it by writing this dot. And this would also do the same thing, because you're saying, hey, this is the game object, get its component. So this game object, get its component. Which component do I want? I want the mesh render. So the mesh render, and what do I want in the mesh render? I want the material. Okay, so in the material, which is this material, get its color, right, which is over here, get its color, and set its color to red. That's all I did. So let's run this again and see if this works or not. And again, since I also have the code for the movement as well, so it's not only going to change the color, but it's also going to allow us to move in the left or right direction. So we're going to hit play. And when I'm going to press the A key, it moves towards the left. When I press the D key, it moves towards the right. One last thing that I'm going to do over here is I'm going to create one last float variable and going to call this public float and call it speed. And we're going to set the speed to, so we can either set the speed over here to about 5 floats, or like 5, or what we could do is, since this is a public variable, we can also change this value in the expector. So we're going to multiply this with speed as well, and when we're going to go back to our inspector over here, we are going to change the speed value to, let's say, 100. Now we're going to hit play. Now when I move towards the left, you can see it's moved faster. If I move towards the right, it's faster, right? And that's because of the speed variable. If I set this back to 1, you can see now it's moving very slow. So you can change your speed variables, speed values from over here as well. So that was the basic introduction to movement, to getting around with translations, to changing the colors. One task that I'm going to give you is I want you to write a code, so that you can move the cube in all. So the first task is going to be, you can move the cube in W and S direction. The second task is going to be write the code so that you can move the cube in all 4 directions. So if I press A key, I would go in the left direction. If I press the D key, I would go in the right direction. And if I press the W key, then I would go in the up direction. And if I press the S key, you would go in the down direction. So that's the second task. And the last task is going to be, if I press the B key, the cube's color should be changed to blue, and if I press the Y key, I want the color to change to yellow. So these are going to be your tasks for this video, and I will see you guys on the next one.